Well, hello everyone, and welcome to our second evolution webinar. These membranes are anti-fouling membranes for food, dairy, and biotech processing. My name is Lindsay Pence, Commercial Support Manager here at ZwitterCo, and I will be your webinar host today. Thank you for joining. A quick little recap on who ZwitterCo is. We are a global leader in membrane solutions for challenging separations. We treat complex wastewaters, purify water for reuse, and maximize efficiency in food processing applications. Our company leverages breakthrough zwitterionic chemistry technology to build membranes that have unprecedented organic fouling resistance. You can see some of our partners and projects listed on this page here, and we are excited to have you joining this webinar so that maybe you can be one of our partners someday. We have three different product families tailored to different water, wastewater, and process separation applications. Our first product family listed here is our Expedition products. These feature Zwitter core technology and are targeted at the most complex and challenging water treatment challenges. You can find more information about them, including upcoming webinars and announcements, on our website. Our second product family mentioned here are our elevation membranes, and these feature our Zwitter Shield technology and are targeted as drop-in replacements for challenging membrane separations and water treatment. And finally, the star of today's webinar is our evolution membrane products. These are anti-fouling membranes designed to be drop-in replacements for conventional sanitary elements in food, dairy, and biotech processing. We have some wonderful speakers for you today. First, we have John Goodman, who's our Vice President of Food Processing and Specialties here at ZwitterCo. He has over 35 years of experience in membranes, particularly in the process industry. We also have myself, which I also already introduced. And finally, we have Scott Brown, who has over 30 years of experience working in the dairy industry, including dairy companies, OEMs, chemical suppliers, and membrane manufacturers. He is our business development manager focused on dairy applications. And before we jump into the rest of the presentation, I wanted to mention that we will be accepting questions for a Q&A at the end of the presentation. So anytime a question pops up, feel free to submit it using the Q&A icon that should be on the bottom of your Zoom, and we will get to those questions at the end. If we have too many questions that we can't get to those, one of our representatives will follow up with you via email and make sure that question gets answered. So please be on the lookout for those emails. All right, let's jump into it a bit more. So since last time we did a webinar in September, we wanted to provide some updates on what's new with Evolution products. As a reminder, we have three membrane types targeted for food, dairy, and biotech processing. Our first membrane listed here is our protein concentration membrane, and this is designed to replace standard 5 to 30 kilodalton polyether sulfone membranes. Then we also have our superfiltration membrane, which replaces tight UF and loose NF in high solids applications. And finally, we have our reverse osmosis membrane, which is a replacement for conventional sanitary RO membranes. All three membranes are now FDA compliant for whey and milk processing and are designed as sanitary spiral elements with a wide range of sizes and feed spacers to fit whatever your system requires. So since the last webinar, like I mentioned, PCM and RO have achieved FDA compliance. Evolution SF had already achieved this last year, and all three membranes are now compliant, including for use with infant formula. We now have bookings for 17 product demonstrations for all three membrane types. Two started last July, and we're using our SF membrane. And most of the rest are scheduled to begin startup in this quarter. So very excited for that. Now we'll get into September webinar poll results, and I'll hand it over to our wonderful Scott Brown.
So when we were last with you via the webinar, we were able to ask a few questions, and none of this is surprising to any of us here. We found that when we asked what productivity challenges do you face, hours of cleaning and excessive membrane fouling, which obviously go hand in hand, were the top two responses. And we are going to dive into that during the course of this webinar today. And the other poll question was, what would you like to learn more about? Field data and installations and deep dive into technology were the top two for that one. And we're also going to talk about those very things today as well. John has a few examples. I have a few examples, and we're really, really excited to share those with all of you.
Thanks, Scott and Lindsay, for hosting. I'll do the deep dive or the brief review of the ZwitterCo technology. We start with Zwitterions, and what are they? So Zwitterion is an organic molecule that has both positive and negative charges in close proximity. So by having both positive and negative charges, it makes it net neutral. And also, it makes these Zwitterions extremely hydrophilic or water-loving. And so they're going to want to bind and hold on to water molecules. Zwitterions themselves, when we open up a jar of Zwitterions, when it comes time to produce the copolymer, they are so water-loving that they will wick moisture out of the air. They're hygroscopic. So the challenge that we face is, how do you make a membrane that's going to be in an aqueous environment 24/7 for a long period of time? How do you make that stable without it dissolving, basically? And the key to that is basically the basis of our intellectual property is a novel zwitterionic copolymer. And that's where the name ZwitterCo comes from, zwitterionic copolymer. And what we do is we make a copolymer between zwitterions and a hydrophobic material, hydrophobic organic material, and that acts as a backbone. It gives it structure so that we can make something that's stable. The zwitterions permanently bond to this hydrophobic backbone to form this copolymer. The video that's been playing is an attempt to capture this. So this new copolymer is still extraordinarily hydrophilic, water-loving, but can be engineered into materials that are stable. And what we do is we make a membrane layer out of it. So obviously, because we're in the membrane business, that's the ultimate goal, is to be able to cast a membrane layer. And on the right is an SEM of our first membrane, superfiltration membrane. And what you can see is that it's a thin film composite. So this doesn't look that different than what an SEM of an RO membrane looks like. You have multiple layers. The layer on the bottom that you see in this SEM is a polysulfone or a polyether sulfone layer. So we do use one of those polymers, just like the PES membranes, for example, used for protein concentration. But then, like an RO, we put a membrane on top of it to create a thin film composite. And that layer that we put on is the zwitterionic membrane layer from that copolymer on the previous slide. The membranes are built from these interlocking copolymer chains through self-assembly. And because the membranes are completely made from this material, that membrane layer, the entire structure is hydrophilic. So again, because the membrane is hydrophilic, highly permeable to water, and the structure stays fully hydrated. Speaking of hydration, we wanted a deep dive into the technology, and I realized, well, this is really dry, but that's what happens when you get a bunch of membrane geeks together. So anyway, please feel free to ask any questions on this. What we're trying to do by making this this hydrophilic membrane is bring water molecules toward the membrane layer that can help protect the membrane from fouling. And we're going to talk more about hydrophilic in a couple minutes. But at the end, organic compounds can't permanently adhere to that membrane layer. And so we can remove solids faster and easier when it comes time to clean. So a bit more about the Zwitter ionic chemistry is on the next slide, please. As mentioned, it's got both positive and negative charges, so it's net neutral. This allows a very high passage of salts, very low surface contact angle. Contact angle, kind of like when you wax a car and you think about water beating on the hood of the car. Something that is more water loving is going to have a low contact angle. Something that is hydrophobic, something that doesn't like water, like when you wax the car, you get big beads and you have a higher surface angle. So this is one of the measurements that's often done. And we've got an extremely low surface contact angle. And as mentioned, because of the cleaning, full performance recovery after exposure to high fat streams. Now, when it comes to that Zwitter ionic membrane layer, it has high chlorine tolerance, like UF membranes. It retains solids, solutes of greater than 1 nanometer, so its pore size is about 1 nanometer, and it has very high passage of salts. And that's true for our PCM and SF membranes. Obviously, with the RO membrane, where the Zwitter ionic layer is acting as a shield, or Zwitter shield as we call it, because you've got an RO membrane, you're going to have high rejection of salts, and you can't use chlorine in those. One of the questions we often get, and it's a lot easier to answer today than it was 5 years ago. How long do the membranes last? How long have they been in operation? First commercial operation of our membranes went in 2021, and so we are getting to the point where we're proving that these membranes are extremely stable in the field. So back to the hydrophilic and hydrophobic aspect. Polymeric membranes. When you think of PES membranes or other spiral polymers, you hear them as organic membranes. And as organic membranes, they are inherently hydrophobic or water repelling. And of course, in these separations that we're doing in food, dairy, biotech, we are dealing with organic materials. And because organic materials are also hydrophobic, that's why oil and water don't mix. Organics are attracted to conventional membranes. And this is why you see fouling by fats and proteins. And it's such a challenge, and why we have to do multi-step cleaning in food processing to get the membranes clean. So membrane companies have been trying to develop membranes that are more hydrophilic, water-loving, to reduce fouling and improve performance. And Zwitter ionic membranes are extraordinarily hydrophilic. Probably biased, but we believe they're also the most hydrophilic membranes on the market. So Scott, being an expert in cleaning, is going to cover why hydrophilicity is so important.
Absolutely, and do it gladly. And now this is my opportunity to tell John that he knows how much I hate the term expert. X is a half and a spurt's a drip that can't handle the pressure, right? But I prefer specialists, but nonetheless.
Scott, I got to set you up I gotta tee it up for you to do it.
But the beauty of the hydrophilosophy is that, just like John said, when we've got that water layer on the surface of the membrane, it makes less opportunity for those foulants to stick. And those of us who have been cleaning membrane elements for years know that that is a big issue for us. And one of the things that we've seen by doing this, by having this great hydrophilicity, is that we can eliminate complete washes and thereby eliminate complete flushes as well. So that's a big piece of this, right? So one of the questions was excessive membrane fouling is a big issue. This is an opportunity for us to show you exactly what we've been seeing in the field. We see less fouling, faster, easier cleaning, higher operating flux, and greater productivity. So by eliminating a wash, predominantly we eliminate the enzyme wash, which is the most expensive wash and the longest wash that you're going to do on your system. We can give you back more time to operate your system. And like I've said on many occasions, any plant manager, production manager knows what an extra hour of production time is going to offer to you in the form of return on your investment. The typical operating flux curve, as we add solids, typically the flux goes down. We see that to an extent with our elements as well, but the fact of the matter is that our gel layer needs to be so much thinner. It gives us the opportunity of getting the same rejection, getting the same production, but now we get a higher flux on production and we remove the foulant a lot faster and a lot easier. So, higher operating flux, maximize fouling resistance with our anti-fouling zwitterionic membranes. We're able to have less adhesion of organics, just like John said. We're not going to see the buildup of the foulant on the surface of the membrane. Now, like I said, we still have to have our gel layer. It's a very important piece of what we do, but the gel layer is thinner and easier to remove. Higher sustainable flux. What we've observed in the field with our trials is that we're seeing higher flux and easier cleaning on when it comes time to clean. But when we get to the higher solids, right? When we get to the back end of that system, and I'm going to show you some graphs here in a little bit that show exactly what we're seeing in the field. And we're seeing a higher flux on the highest concentration of the product. One of the plants that I've been working with, they were seeing flux rates get down as low, just get down extremely low. And it's like I say, it's at the back end of the system. So we expect the flux to be lower. But when compared to what we're getting today with our elements in that same stage, we're seeing higher fluxes and better rejection of protein. At the end of the day, what we're after for you is increased productivity. As a former plant production manager, that's what all of the talking heads want to talk about, right? They want to talk about higher yield and more uptime on production.
And that's where we found that our value focus, when we first started talking with customers, before we had FDA, the only testing that could happen was in the lab. And so in a short trial, you could definitely test the membrane and look at the performance, and you could see how easy it was to clean. So that's where we focused initially. But then, and this happened last summer, really, when Scott joined ZwitterCo, we started talking to production managers. And what did you hear, Scott, regarding the importance of cleaning versus time and production?
The same thing I just mentioned a moment ago, John, and that's the beauty of it is that yeah, we're going to save you on your most expensive, your high cost chemistry, right? Like John said, on the UF elements, we can wash them with chlorine, which is a low dollar chemical, right? As opposed to 10 times the amount that you pay for your enzyme. If we can eliminate your highest cost chemistry and clean with a lowest cost chemistry, we're way ahead of the game as far as cleaning. But that's not where the big savings is, not to me. If I can give you another hour of production every day, think about what that ROI is with your whole system. Even if you're not needing to run the system, you've got an extra hour a day to do PMs. We all know PMs are something that rarely happen in a dairy plant. We run them until they shut them down, right? You've seen that as well, right, John?
Of course, of course. So
So
we've definitely changed. If you've been watching ZwitterCo for the last couple of years, some of our messaging for our evolution products has definitely moved from um, cleaning toward productivity.
and the cleaning is still important. And the savings on the cleaning is still important. But at the end of the day, we're also looking at sustainability, right? That seems to be the new hot topic with everybody I talk to is water savings, energy savings. If we can remove one full cleaning step, now we remove one full flush step, right? You guys know exactly how much water goes into those flush steps. I know you do. And that's going to take a lot of the pressure or some of the pressure off of your wastewater treatment system. These membrane systems are all water hogs. We know that, right? And we know how much water is necessary to flush these systems out. You remove one full flush, that's going to turn into something.
So Lindsay, as we end this section, we've got a poll.
Yes. We have our first poll. I will open this and go through the question here. So the first poll question is a follow-up from our last webinar when you identified excessive fouling and hours of cleaning as the greatest productivity challenges at your facility. So please take a moment to answer this question before we move on. A shorter cleaning program will allow my facility to increase production, do more membrane system maintenance, lower cleaning costs, perform other preventative maintenance, save water, or enjoy fewer emergencies. And you can only choose one answer, so choose the one that resonates with you the most, even if several of them do. We got some answers still coming in. And thank you for
We
the
do appreciate
participation.
all of
Yeah,
you taking these polls. It gives us a great deal of information and the next place to go with our future webinars as well.
okay. Give it a few more seconds here before we end the poll. Get those answers in if you'd like to be included. Well, there we go. There's a little burst. Okay, last call for the poll. All right. Thank you for your answers. We'll do a quick share of results, and then in our next webinar, we'll go into a deep dive. So it looks like what Scott and John have been saying on increased production really resonated with folks. Scott, Goody, you have any
Same
comments?
point.
Yeah. Both of these answers are just shocking to me, right, John? It's exactly what I would expect to see. Anytime we can increase production and save water, again, the sustainability piece has become a very important part of everything that goes on in our plants.
Definitely. Well, thank you all. We'll move on and we'll have another poll later. So we'll continue on into some field data.
So I'm going to take this one. Scott and I are gonna trade off here based on who's working with the customer. In this case, this is data from a WPI process at a large whey processor in the Midwest. This is from their final concentration system. And actually, this site was the first to install our Evolution SF membranes. They installed them last July in their last two systems in their process. And we are what, 6, 7 months in now. Membranes are continuing to run very well. So we are at obviously the high solids range. In this case, being the final system, the feed total solids are 28 to 30%. And they're running in parallel with conventional UF, so we can get a side-by-side comparison. We're seeing, or the customer's seeing, no measurable difference in permeate in either system. This just happens to be from the final system. And this was a snapshot of data. I visited on the 19th of January, so they collected some data in the days leading up to that. And as you can see, normalizing this data with the conventional membrane in black, normalized to 1.0 on the first day here in January where the data was taken. There's on average 20% higher flux going through the membrane, going through the ZwitterCo SF membrane without the measurable difference in permeate. So this one, both this system as well as the UF in front, where the solids are in the 25 to 27% range, we're seeing some really good data outperforming the conventional membrane on flux. So Scott, why don't you take the next one?
You bet. So this is one that I'm kind of wound up about these days. This is a MPC system in the southwestern United States. The elements were installed in both stages, 14 and 15, at the same time. So our elements are in stage 15. The conventional elements are in stage 14. And you can see here where the flux is this the solids basically are very close to one another. We can see that the solids in the stage 15 are a little bit higher, but not significantly. But the average protein in the permeate, we're rejecting the protein. We're keeping all the protein, and we're not passing that through into the permeate. And on the very back end of this MPC system, where the solids are the highest and the flow is the lowest, we're getting really, really good results, and better than I had actually expected to see. And then the protein in the permeate from stage 15 is now about a third of what it was in the last set of the membranes at the end of the run. So we'll keep you dialed in. We'll show you these results again later on in subsequent webinars. But the trial is going as well or better than any of us had expected. So we're excited about this one.
And now that there's field data being shown, I want to remind everyone, feel free to submit your questions and we'll be answering those at the end here shortly.
So,
And Scott, this is another one of yours.
yep. So one of the great things that we've done is there's a system in the upper Midwest where the plant is recovering all of their production flushes. So all of the production flushes from everything in the plant, from separators to clarifiers to membrane systems, silo flushes, everywhere in the plant, they're collecting the production flushes. And then they put it into a giant silo. And prior to installing our elements in this plant, they were doing 2 enzyme washes, and they were doing the basic alkaline pre-wash or junk wash, as I like to call it, 2 enzymes, an acid wash, and then a final alkaline wash on an RO. By installing our elements, we've completely eliminated those 2 enzyme washes. But here's the cool thing, where this is a system that it's not for food grade, but it is a very vital piece for this plant. They went from washing it daily with 2 enzyme washes to now they're running 72 hours straight with no wash and eliminated the enzyme washes. And we're still running a baseline at lower than 250 psi. The system runs great. They run for 72 hours straight. They shut it down. They do this abbreviated wash with a junk wash, an acid wash, and then another alkaline wash. And then they fire right back up when they get going again and then run for another 72 hours. I believe that this is a wonderful example of what we can do for you in the field.
And the next one is showing is one that we've shared this data before, but now it's been updated. So this was from our first installation of RO on a effluent application, and whey processor making WPI. And what we're doing is taking UF and NF permeate streams that are going to wastewater. And the purpose of the RO is to reduce the hydraulic load on wastewater. And system has now been running with our membranes for almost 2 years. During that time, they haven't done a single enzyme wash. Here is data from the last 550 days or so, about 18 months of data. And you can see we've normalized the flux back to 1.0 on start. And probably should have done a line across, but as this is getting long, there's been some ups and downs, and that's mainly because we have run various cleaning experiments. Because this was our first installation, it was a great opportunity to work with the customer to try different things, and it's been a great learning experience. Most recently, if you look about 4 or 5 months ago, the flux had dropped down, and all that we did was we bumped the temperature from 90 Fahrenheit to 100 Fahrenheit. So we had been cleaning at a pretty low temperature, and you can see that membranes recovered and have been plugging along. And in just the last 10 days of the chart, you can see where it's been above the 1.0 and slightly below. But we're sitting here. Membranes are still performing, and this just goes on from what Scott was just mentioning. Customer used to use enzyme every day, and now we've eliminated the enzyme step. And the other big thing on this is reduce the chemical cost. Looked at the month of January, and the chemical costs were 65% less than they were back in late 2023 when the economic analysis was done for the system. So we mentioned that we've got 17 different production demonstrations that are scheduled. So that's in addition to the 5 operating systems that we have on effluent and wastewater with our RO. And here's some of the different applications that we have for the different membranes. And Scott, I know one of them that you're really excited about is replacing NF and WPI.
That's a big deal. If we talk about replacing the NF with SF in the WPI, now we're seeing the same protein rejection that you're getting, or maybe even a little better. We are passing some lactose. So we have to consider for a couple of things when we do this. We have to consider lowering your ratio, or actually lowering your ratio on your UF prior to the system, your NF, because you're going to lose some lactose in the NF. So we want to make sure we're keeping an eye on our lactose passage. Also, we need to keep in mind that lactose is going to be in the permeate. Typically, we take that lactose or that permeate from the NF and send it to a polisher where we concentrate the solids, send those solids back into the system somewhere farther upstream so that we don't lose those solids. But we just need to bear in mind that with that passage of lactose, it'll drive our protein a little higher. And we're also going to have, again, that lactose in the permeate. So that has to be a consideration. But now think about this. If you can wash your NF with chlorine, which you've never been able to do, right? Because it's a TFC, it's a thin film composite that will oxidize, and that NF membrane will completely fade away if we wash it with chlorine, right? Now we can put that SF in there, which is a very tight UF, and now we can wash that NF system with chlorine daily. Now, when I say wash it with chlorine, we talked about high chlorine tolerance. We still want to keep that in the standard range between 180 parts per million and 200 parts per million during the wash. And we want to monitor that. That's a big piece of it. If we put the chlorine in it and the chlorine is getting consumed and we're dropping that chlorine parts per million down below 150 to 120, 100 even, we want to make sure that we're redosing that chlorine to keep that chlorine level between 180 and 200 parts per million. But these elements can take it every day, every wash without having any issues at all. And it gives us a certain bio effect as well. Where we know we're using that chlorine, it gives us a sanitizing ability as well.
So this lists the demonstrations in the dairy industry. Most of the PCM and SF applications, probably no surprise, are going to be on skim milk, MPC, WPC. We are then looking at SF toward the higher solids applications, between MPC and WPI, MPI. And then also really excited about RO. It's a product that we've been working on scaling up right now in manufacturing, and we'll be shipping very soon to get the RO trials going. And we've got trials scheduled in skim milk concentration, UF permeate, of course, lactose, and polishers. So we've proven it on effluent and wastewater streams, and are extremely excited to get it onto product. So Lindsay, why don't you take it away, please?
Sure. We have one final poll for you all. So, following our conversation on production demos, please take a moment and let us know your highest priority production goals for 2026. Is it lower costs, increase volume, sustainability, produce higher value products, facility expansion, or waste reduction? And again, you can choose one, so choose the top answer that resonates with you the most. And thank you again for interacting with us during this webinar, and also feel free to continue submitting your questions for the upcoming Q&A. We've still got some answers coming in. Give it a little more time. Any final poll answers out there? Few more seconds here. All right, thank you for those who answered the poll. Let's take a quick look at results. A lot of things are important. I don't know, Goody or Scott, what thoughts do you have immediately?
Not surprised about increased volume. I mean, we all know the demand for protein is through the roof. The value of protein is up. Interesting, again, the numbers. Produce higher value products. I know definitely both Scott and I are having conversations with customers who are interested in producing a higher protein content because of just the market demand right now. Scott, any comments you have?
Exactly what I would have expected. Like you said, John, increased volume is a huge piece of what every plant person deals with daily, and what they're being tasked with is to try to increase what they're able to run. And I back in my days with the OEMs, every time we designed a system at about 20 to 25% higher than what the customer was asking because we knew they were going to run it there anyway, right? So if we can increase your volume without having to add stainless steel, it kind of bums out the OEMs, but it'll help you at the end of the day with your bottom line.
Well, we'll dive more into these in our next webinar, and thank you all for answering. Let's continue on here. So we have reached the Q&A section of the webinar. So feel free to continue submitting your questions as we go through them. Scott and Goody, are you ready to answer some questions here from our wonderful audience?
Absolutely.
Always.
Okay, let's start with one. Due to the low surface contact angle compared to polymeric membranes, is there any difference in transmembrane pressure?
Yeah, I mean, this is obviously a different membrane chemistry, but what we're finding in the field operation for really all of the membranes has been their direct replacements. So all the data that we're providing, the RO operating in these wastewater and effluent plants, the SF elements and PCM elements that have begun operating in place of UF, customers are all operating at the same conditions they were operating before.
Great. And this
and I do want to mention that's operating flux. You will find that the water flux is
Clean water flux.
Clean water flux is lower, but the important thing is operating flux, and that's where once you start getting gel layer, as Scott had talked about earlier, and the again the hydrophilic nature of the membrane, the anti-fouling nature of the membrane, that's where you start seeing higher flux at the same operating conditions.
And as a former person that worked with cleaning these elements, right? It's more important to get the flow over the top of the surface of the membrane than it is to get the flow through the membrane itself. Where's the foulant? The foulant's on the surface. I want that flow, and I want that the turbulence, right, to remove that foulant off the surface of the membrane. So clean water flux is a great indicator, but don't try to compare the clean water flux between the ZwitterCo element and the conventional element. Compare it from the beginning of when you install the ZwitterCo element and as it progresses through the process. Because I think you're going to find that the clean water flux, although lower on our elements, it's going to stay basically the same during the course of the whole time that you're washing them.
Yep. Thanks for mentioning that.
Okay, this is a quite common question, so I figure we just get it out of the way. How about cost economics of zwitterionic membranes versus traditional spiral wound membranes?
Listen, we're selling a value-added product. You know, we're talking about the benefits, and ZwitterCo membranes are more expensive than a conventional membrane in terms of a price tag. However, we've based that price on the economic value delivered, and the intention is to offer customers a lowest total cost of ownership. And if we can increase production, think about how much money that is worth. If we reduce the cleaning chemicals by 50, 60%, the example I gave, 65%, that's all money. And so what we've done is we have offered two different sales models for our product: a one-time sale with the industry's best warranty, as well as a subscription model, which basically allows you to pay a monthly operating fee, and basically that the operating fee is going to be a fraction of the overall savings. Lindsay, do you think I answered it?
Yeah, I think that's pretty good. And
I
we
hope
can
so.
always follow up further if anyone would like.
Yeah, I mean, listen, Scott and I will be glad to talk price. Obviously, we don't want to do it in a public forum, but please feel free to send in the question, and we'll contact you and talk to you.
Okay. Since the membranes are extremely hydrophilic, is there a risk of affinity of the membranes with other polar components, say, that are in cleaning solutions?
It's a great question.
I
So
figured you'd like that, Scott.
one of the things that we always hit on is that these elements need to be cleaned with a non-ionic surfactant. So what we prefer and what we need to have is we need to avoid the anionic surfactant. So in your RO, you would typically use an anionic surfactant to clean that element. We're going to ask you to use a non-ionic surfactant with no charge because it does make a difference on the membrane itself.
I am going to, I'll add to that with our newest evolution products, the membranes have at least 50,000 part per million hours of tolerance to anionic surfactants at 50 degrees C. And so when we run our production demonstrations, we aren't having the customers change their cleaning. And if you think about it, a daily cleaning, even if you're using detergents or cleaners with anionic detergents, or running an enzyme that has an anionic, a daily exposure might be 250 to 750 ppm hours. And so
it's going to take a while to get to 50,000.
Exactly. So no one's going to run a production trial of one stage of elements and change their entire cleaning. You couldn't do that because
and we wouldn't ask you.
Won't get cleaned. So the membranes have tolerance, but when it comes time for a full system, as Scott said, we're going to strongly recommend and work with you and your cleaning company on a cleaning program to optimize savings and to go to non-ionics, just to get the longest life.
Okay, thank you. A couple quick burst questions just to talk about application suitability because we're trying to get through them all. Are your membranes suitable for brine UF and the concentration of whey to WPC 60 to 35% total solids, or is that too optimistic? So two separate applications. Just give a quick yes, no, great.
Great is absolutely right.
Yeah.
We definitely can run in the brine UF without any issues. As far as concentrating to 35%, I'm not seeing that as being an issue with WPC, any of them. WPC 80, WPI, it's not going to be an issue. Matter of fact, we're probably going to drive your solids higher than you are currently than you're currently pushing them.
Great.
Yeah, and a brine UF, PCM and SF membranes have extremely low salt rejection, so they're gonna operate as a direct replacement for a UF in a brine.
And the big thing in a brine is going to be bacteria and fat, and we love rejecting all those things.
And the key is that the membrane is going to clean up a lot better
and quicker
in that.
Yeah. Definitely. So one quick question that I'll just answer. Someone is asking if our evolution membranes fit into existing housings and if the dimensions are the same. Evolution membranes are designed to be drop-in replacements, so they are available in the same conventional sizes that you would already use, so you don't have to make any system changes or capital expenditure to use evolution membranes. So let me move on to another question that you guys might find interesting. Is chlorine-free cleaning possible?
Yes, it definitely is possible. And obviously, Scott and I are Americans. We're sitting here in the United States. And so most of our customers are using chlorine in their cleaning. And but I think we've proven it with the RO on the wastewater streams that cleaning can certainly be done without chlorine. And it is something that I've talked to a couple customers about, where from a quality standpoint, with their WPI product, they'd like to move away from chlorine so they can reduce chlorates in the product. And so again, the membrane is going to clean up a lot better than a conventional membrane. And we've got different tools that we can use if we may find to optimize that we do a periodic enzyme. But we look forward to the opportunity to have full installations where we can prove it out by modifying the current cleaning. And I would love to get to the point where we could eliminate chlorine if at all possible. And I know we're also talking to companies over in Europe, Western Europe, where they're not using chlorine.
Okay, we only have time for a few more questions, so let's see if we can get through them. How does a standard CIP procedure look for whey concentration with either RO and UF? What are the membrane limitations regarding pH and temperature?
That's a great question. And it's a standard wash. We're going to do a alkaline junk wash. We'll move to an acid wash, then an alkaline. And when I say alkaline, I mean alkaline and the surfactant. So, and when I say this is when the full system is loaded with the Zwitter ionic elements. So we would do a alkaline junk wash, do an acid wash, and then do an alkaline wash. This is for RO. And then for UF, we would do an alkaline junk wash, do an acid wash, and then alkaline chlorine wash at the final. As far as the pH tolerance, it's the exact same as your conventional elements that you're using today. So we want to keep that pH on the alkaline wash a little less than 11. I prefer to see between 10.8 and 11 on the alkaline wash, and then on the acid wash in the 1.9 to 2 pH range. Did I get all of the questions asked?
And then what I was going to add to that, Scott, is for our newest evolution products, the cleaning temperature 50 degrees C, 122 F max, just like you'll see.
Just like conventional.
And the other is you can definitely sanitize with peracetic acid, hydrogen peroxide solutions.
Absolutely, yep.
And we've got customers with the RO who are doing that on a regular basis.
So this is interesting, almost less technical, but I'm sure you have this discussion with customers a lot. Other than cost, why would people not want to use ZwitterCo as opposed to other manufacturers? I wonder that every day.
What we're seeing in the field is proving this out. And to be perfectly honest, it's why an old dinosaur like me decided to join this vibrant young team with the smart people, because they've come up with something that, after being in this industry for 30 years, that I've seen something completely new. And that is the exciting thing. And why wouldn't you want to use our elements?
Yeah, of course, I had to laugh. We're used to, of course, promoting our product. Why wouldn't? I think change. We're all humans, and everyone. We're doing production demonstrations because you're all. I mean, basically the poll questions. The production managers are under pressure to increase production. They can't afford a hiccup, and it is something that's different. And so, generally people want to test something new before they go and implement it throughout their plant. And of course, that's why we're doing the production demonstrations. But one of the questions that we always ask is, how long do you need to see it before you move to the next step? And I obviously, from our perspective, we would love it if everyone is ready to jump in with both feet.
All right, we'll do one final quick question and then we'll wrap it up here. But please feel free to continue submitting. We have several that we'll need to follow up via email, and we will make sure everyone gets answered. All right, the last quick question: is the technology also suitable for organic biopolymers at 55C?
So right now the PCM and SF are rated. I believe we've got 55C, 131 Fahrenheit on the data sheet as continuous operation. We have done some testing with specific customers at 60C at 140 Fahrenheit continuous operation. I know we've got some data that where someone ran for about 3 months at that temperature. So we are confident that we can go to a warmer temperature. However, it is still a new product, and we learn through these demonstrations. So the specific application sounded like it was biotech, and it sounded like it was elevated temperature. Um, I look forward to following up with the person who asked the question.
All right, great. So we will follow up via email, and we thank you very much for your questions. As we wrap it up here, we want to remind everyone that we have a wide variety of additional resources on our website, including in-depth case studies for even some of the data you've seen presented today. We also have a fascinating webinar that talks about evolution membranes. It's great to listen to while you're driving to work or, walking around the plant doing something. So feel free to check those out. And if you have any further questions, you can always send an email today. And John and Scott, thank you so much for your participation and being willing to present. And to the audience, we couldn't have done this without you, so we really appreciate your participation. With that, I think we will end our webinar and hope to talk to you guys soon. Thank you.
Thanks for joining.
Thank you.